Hello my dear friends, how are you all? All good? Yeah, this is Bharati. I welcome to everyone at the eCareerPoint YouTube channel. Here we are doing previous year questions as your exam is coming near, so you need to practice questions, right? So today we will discuss the questions of P block chapter. In previous class we have discussed about the hydrogen and S block element. These inorganic chapters are like you have to remember all the things. So more practice, more confidence in these chapters. Okay, so this is NEET crash course, 60 days crash course. You can register yourself in this course as the last time push is very important for any student, last time effort, so it is very important. You can enroll yourself in this course. And your friends or your siblings who are in 10th or 12th boards, or if you are appearing in 12th board exam, so you guys can download the sample papers of 10th and 12th class in the which are given in the description link. Okay, so you people go to the description link and download these sample papers and practice, because when we prepare for the entrance exams, right, when we prepare for the entrance exams, so we only focus on the MCQs, right? So our mind is completely deviated from the subjective questions and all. For this practice you need sample papers. So you just go and download this sample paper, which are totally free, and you can get them in the description link. Okay, this is for your friends who are preparing for JEE. We have the great opportunity, because as we all know that JEE exam is completely online. So yeah, there are 4 attempts and 26 papers. Last year 2021 the 4 attempt and total 26 papers are given in the description link. Go to that link and you can go to the online platform where you can try these question papers or sample question papers, yeah, 2021, so that you can more you can do more practice for the online platform also. Okay, now if you like my sessions or you like the concept that I teach here, you can follow me on the eCareerPoint app. You just download the eCareerPoint app and follow there, so that you can see my updates, regular updates there. Okay, so let's start the P block chapter. Are you guys ready? Yeah, chaliye. Which one of the following element is unable to form MF6 3-? The element which cannot form MF6 3-. This is the complex. Out of these 4, which element cannot form this type of the complex? It is so simple thing. See, we have the coordination number is equal to 6 for this complex. That means it will require 6 vacant orbital or 6 electrons to pair up. 6 vacant orbital should have to this element or to this metal, so that this coordination number 6 and this complex can be formed. But as you see, these 4 elements, boron does not have the d orbital, whereas this aluminium, indium and gallium, these 3 have vacant d orbital, but boron does not have any kind of the d orbital, so it cannot expand its valency. No expansion of valency. No expansion of the valency. No expansion of valency. Boron cannot expand its orbital, that's why it cannot form the complex which have 6 coordination numbers. So right option will be A option, that means boron cannot form MF6 3- type complexes. Okay. Next question, the tendency of BF3, BCl3 and BBr3 behave as Lewis acid decreases. That means I have 3 molecules BF3, BCl3 and BBr3. I have these 3 compounds, right? Now I'll tell you the sequence of Lewis acidity. Now see, you all know that back bonding concept. Everybody knows about the back bonding concept. If there is back bonding in the molecule, that means its Lewis acidity will decrease. Yes, Lewis acid character is inversely proportional to the back bonding of that molecule. Okay, now see, I have three compounds BF3, BCl3 and BBr3. For back bonding we require similar size. We require similar size of orbitals, right? The orbital which are doing back bonding, which are participating into the back bonding, should have the same or similar size, so that the back bonding could be stronger. So in these three molecules, boron and fluorine has better overlapping. It has p orbital, it has p orbital. Better overlapping, better back bonding, that means Lewis acid character will be less. Clear hai? So better overlapping in BF3. Then BCl3, then BBr3, because as the size increases down the group, orbital size will also increase, and if orbital size and the boron orbital size are not matching, that means back bonding will not be good. If back bonding is not good, that means Lewis acid character is good. Okay, so Lewis acid character will be higher in BBr3, BCl3 and then BF3. So right option will be right. B option will be right. Okay. Moving to the next question, which of the following molecular hydrides act as a Lewis acid? Lewis acid that can accept the lone pair, okay, that can accept Lewis acid, that can accept the lone pair, okay, and which one will accept the electron, which will be the electron deficient? So nitrogen has a lone pair, it is not electron deficient. Water, in oxygen we have two lone pair, it cannot behave as Lewis acid. In CH4 we have 4 electrons in carbon and 4 electrons are shared by hydrogen, so it is electron precise. And we require electron deficient molecule that can behave as Lewis acid. So B2H6, okay, B2H6, diboron, B2H6 diboron. It has 3-centered 2 electron and an electron deficient compound. So if it is electron deficient compound, it will behave as Lewis acid. Okay, I hope this is clear to everybody. Moving to the next question, which of the following structure is similar to graphite? What is the structure of graphite? I think graphite is like, yes, okay, it's not moving, so let's do something else. No, we all know that benzene is this, sorry, graphite is this. This is my graphite. Similarly, one layer, similarly another layer. Okay. Now it is asking which is similar to graphite. We all know about BN. Boragine. B3N3H6. BN is boragine, B3N3H6, which is also known as inorganic benzene, It has the structure similar to this one. B, N, and this. Okay. Hydrogen. It's like that. Okay. So it will be B3N3H6 and this is inorganic benzene. This is known as inorganic benzene. This is known as inorganic benzene and similar to the graphite structure. I hope this is clear to everybody. Okay. So right option will be A option. Moving to the next question. The stability of +1 oxidation state increases in the sequence of +1 oxidation. We have heard about inert pair effect, right? Down the group, as we go down the group, so due to inert pair effect, lower oxidation state is more stabilized, right? Lower oxidation state is more stabilized. So if I talk about the boron family, boron, aluminium, gallium, indium and thallium, they can exist in +1 and +3 oxidation state. So the molecules higher in the group will exist in +3 form and lower in the group will exist in the +1 oxidation state. So down the group, +1 oxidation state is more stable. So thallium will be more stable than indium, gallium and aluminium. So A option is the correct option. Okay. Now see this question. Which of the following statement is incorrect? Which statement is incorrect? See. SiCl4 is easily hydrolyzed. Yes, SiCl4 can be easily hydrolyzed because it has the vacant d orbital where the water molecule, the lone pair of water molecule can be donated to the vacant orbital of silicon. Okay, so SiCl4 is easily hydrolyzed. GeX4 is more stable than GeX2. हायर इन द ग्रुप के अंदर Ge+4 ऊपर के साइड Ge+4 इज मोर स्टेबल. अभी किया था हम लोगों ने कार्बन, सिलिकॉन, जर्मेनियम, टीन एंड लेड Pb. इट कैन एग्जिस्ट इन +2 and +4. सो above higher molecules exist in +4 and lower molecule exist in +2 due to inert pair effect. So GeX4 is more stable than GeX2 because here germanium is +2, here germanium is +4. Out of these two, SN4 is ionic in nature, PbF4 is covalent in nature. SnF4 and PbF4 both are ionic in nature. Both are ionic in nature according to Fajans rule. Both are ionic in nature. Okay. So this one is a wrong statement. D is incorrect statement. Okay. Chalo. Moving to the next question, the basic structural unit of silicate we all know SiO4 4-. SiO4-. This is the basic structural unit of silicates is SiO4 4-. What are silicate? The anions of the silicon and oxygen are silicates. So SiO4 4- is the basic structural unit of silicates. Is it clear? Which of the following oxo acid of phosphorus has strongest reducing property? Reducing property. What is reducing property? Reducing property, that means reducing nature. To reduce others. And oxidize itself. Clear? So, out of these 4 compounds, which compound can oxidize itself to the higher oxidation state? So, firstly we have to see the oxidation state of phosphorus in every compound, right? H4P2O7, by X method it will be +5, right? 4 + 2x - 14 is equal to 0, it will be +5. H3PO3, it will be +3 - 6, it will be +3, right? H3PO4, it will be +5. H3PO2, it will be +1. So, out of these 4, which can go to the higher oxidation state? +1, that can go to the +5. Is it clear? So, H3PO2 will be the strongest reducing property. These two cannot. Why so? Because they are already in the higher oxidation state. They can't go to the more higher oxidation state. So they cannot oxidize itself, they cannot behave as reducing acid, okay. And out of H3PO2 or H3PO3, H3PO2 is stronger reducing agent because it can oxidize itself to the more higher oxidation state, okay. Moving to the next question, identify the incorrect statement related to PCl5. We have PCl5. Phosphorus has 5 valence electron, right? 5 electrons are shared by chlorine. 5 minus 5 is equal to 0. That means 5 bond pair plus 0 lone pair. 5 bond pair plus 0 lone pair. That means sp3d is the hybridization. sp3d is the hybridization and triangular bipyramidal TBP will be the geometry or the shape of this PCl5. So see, P, Cl, Cl and Cl, this is axial Cl and Cl. Now see which one is wrong statement. Two axial PCl bonds make an angle of 180, yes, this 180 and पीछे से 180, clear. Axial PCl bonds are longer than equatorial, yes, these PCl bonds are longer than these ones for feeling less repulsion or more stability. PCl5 molecule is non-reactive. It is incorrect statement because PCl5 on heating gives PCl3 plus Cl2, also it gives H3PO3, H3PO4 molecules, right? So C is incorrect one. Last one is 3 equatorial PCl bonds make an angle of 120 degree with each other. With each other, yes, 120 degree. These bonds are 120 degree. Yes? Is it clear? C option will be a right option. Now see this one, the correct order of an compound in its decreasing order of oxidation state. We have to calculate the oxidation state of each of the nitrogen element so that we can arrange in the decreasing order, okay. Let's calculate the oxidation number. I have HNO3. HNO3 has plus 5 oxidation state. Oxygen minus 6, minus 2 into 3 minus 6, this plus 1 minus 5 will go to that side plus 5, okay. In NH4Cl, if it is X, it is plus 4 into 1 minus 1 is equal to 0. So X will be minus 3. This nitrogen is minus 3. Alright. Next one is NO. Oxygen minus 2. So nitrogen is plus 2 because nitrogen is less electronegative than oxygen. So it will be plus 2. Right. And in N2 oxidation number is 0. So decreasing order. So सबसे पहले it will be plus 5 decreasing order, right? So plus 5, then plus 2, then 0, then minus 3. That means HNO3, then NO, N2, NH4Cl. So I think C option is the correct one. I hope this is clear to everybody. We have to calculate the oxidation number of each compound. Clear? So C option is the correct one. The species having bond angle of 120 degree. Which species has the bond angle of 120 degree? As we can clearly see that it is the compound BCl3, boron family, which is sp2 hybridized. It will have the geometry triangular planar in which bond angle is 120 degree. Yes, pH3 is a Drago molecule. pH3 is a Drago molecule in which there is no repulsion and the molecule exists at 90 degree angle. Is it clear? ClF3, T shape, 2 lone pairs, T shape hoga. NCl3, it has a single lone pair, right? So it will be pyramidal in nature. BCl3 is triangular planar having 120 degree angle. So D is the right option for this question. Is it clear everyone? Yes. Next question, maximum bond angle at nitrogen is present in which of the following? Just calculate the hybridization. From hybridization we can get an idea about the geometry and shape of the molecule, right? And then we can easily get an idea about the bond angle. So let's calculate the hybridization of each one. See, If I talk about NO3 minus, sp2 hybridized 120, sp2 120 degree, NO2 minus bent shape, say 5 plus 1 6 minus 4 2, 1 lone pair 2 bond pair, that means it will be bent shape, that means less than 120 degree. Now see this one actually NO2 plus is sp hybridized, that means 180 degree, which is maximum bond angle. 180 degree is maximum bond angle. So NO2 plus is the molecule in which this bond is maximum 120 degree. Okay, is it clear? So this question, strong reducing behavior of H3PO2 is due to, in previous question we have seen that out of those 4 molecules, which one was behaving like strongest reducing agent? Which one? It was H3PO2, because in H3PO2 phosphorus is only +1 oxidation state and it can go to the +5 maximum. It can oxidize itself to the higher oxidation state. That's why H3PO2 is stronger reducing agent out of these acids. Okay, oxo acids. But why so? H3PO2, see its structure. P double bond O, either OH, this is H, this is H. It has 2 pH bonds and 1 POH bond. So the +1 oxidation is because of this OH only. It can give only this hydrogen. It is monobasic in nature. It can donate only one hydrogen. If you see H3PO2, some of the students will try to write it PO2 3 minus. No, this is wrong, because other 2 hydrogen are directly joined with phosphorus, and phosphorus and hydrogen are has very less electronegativity difference. Okay, so it is monobasic in nature. It will exist in the +1 only because of this hydrogen. So right option is presence of 1 OH group and 2 pH bond. It is more reducing nature. I hope this is clear to everyone. It was these were the questions from the P block. So all the questions are from the NCERT. Just read the NCERT. After reading the NCERT, attempt question and questions will be good to you. Okay, clear? A is the right option. Now the students which really want to join this crash course, 60 days crash course, you can register yourself in this course, because it will be helpful for you. What this course will give to you? 200+ live classes by expert faculties, biochemistry and physics. 15+ consolidated tests will happen during this course. 7,200+ practice problem with detailed solution you will get through this solution. So if you want to join this one, download the eCareerPoint app and enroll yourself in that course. Is it clear? Yes, download eCareerPoint app and follow me in that app. Okay, so that you can get updated for my sessions and for other things in the eCareerPoint happenings. Okay, so I hope this session was good to you. So your exam is coming near. Work hard and do the NCERT only. Okay. I'll come with the NCERT series on the another channel, so you guys can join that session also. Okay, so it will be very helpful, because at the end time, see, we do everything during our coaching sessions and other things during test. We read everything, we learn everything, but at the end moment, because we have only 2 months for the chapter for this exam, so we should do what we have to. Okay, so I'll announce the date from when I'll start the NCERT series. Okay, so you guys join that series also. It will be very, very helpful to you. Okay, Okay guys, thank you so much. Stay well. See you soon. Take care.